Welcome back to our session on measuring information transfer in complex systems. In this short video, we'll consider contrasting the concepts of information transfer and causal effect. So thinking about causal effect, what I mean here is the pearl view that causality is about the effect of interventions. Information transfer, in contrast, is about modeling the dynamics as computation, taking this information processing perspective. Okay, it's a perspective that we're taking here. We can think about the difference between these two concepts through examples. We could go back to the heartbeat example and think about what the differences would be there. We know what we've seen already when we've thought about the concept of information transfer there. If we think about causality, then obviously every time we have a zero in the source to a zero in the target, we have the same causality. We see something different if we think about modeling information transfer. We see much more information transfer when we look at the transitions in the target. That's not something that causality sees. So the concepts are quite different. I don't believe that one is better than the other. They're just answering different questions. Okay, causality is asking the question about the effect of interventions. Information transfer is asking a question about how to model the dynamics. Different questions. We can see this similarly if we look at these two processes that we first came across in our information storage session. Here, the dynamics look exactly the same, with x and y just a series of alternating ones and zeros. The causal attribution between these two processes will be very different, as you can see from the arrows in the diagram. And yet the information processing model perspective would attribute information the same way, modeling both of these processes as being solely information transfer in x and y and having no information transfer. Again, one is not more correct than the other. They're different concepts answering different questions. Okay? If we want to model information processing the way it's described, then we take this perspective of looking at storage first and then transfer, and that gives us the same answer in these two processes. To take that further, as I say, they are both concepts are giving useful information, just to different questions. So importantly, we need to understand that information transfer does not directly measure causal effect. Causal sources can serve information storage only. Okay, and that's particularly the case if we've got feedback loops in our system. So the sources there may be serving information storage only, even though they're between different variables. Furthermore, non-causal sources, for example, hidden common drivers, could actually have transfer. We should try to restrict our analysis for information transfer to causal sources where possible, so we can get a more useful interpretation, a more useful model, if you will, of the information storage and transfer. In contrast, then, let's think about what information transfer modeling adds that causal approaches do not. And that is in particular that they are able to measure emergent computational structure. We see this in the simple transitions in the heartbeat example, that the information transfer highlights why we think there is much more information transfer at the transitions, whereas causality approaches do not. Similarly, as we'll see later in our session, gliders in cellular automata are highlighted as very strong information transfer entities when we model information processing, and yet causally they are generally no different to what's happening in the background domain. So these concepts are complementary. They both are answering very relevant questions, but they're different questions. They're different questions. They're complementary. It's useful to have both. Here we're really dealing with the model of information processing, and that's why we're focusing on transfer entropy. It's not to take anything away from the causal approach. It's asking a different question. In our next short video on information transfer in complex systems, we're going to look at measuring information transfer in practice and looking at setting the embedding parameters, for example.